Hello everyone, welcome to this video lecture. In this lecture, we will discuss the paper solution of GTU. This video covers the topic Infinite Series for BE Semester 1 and 2 students. We will solve and explain the questions step by step to help you understand the concepts and the exam approach. This paper is from the GTU Summer 2025 examination. Let's begin with the paper solution. This is a paper of Summer 2025 for BE1 and BE2 students. In this paper, question number 3, this question and this question. These two questions include the sum of infinite series. See here, this question contain total 6 questions. Okay, so in this video lecture, we will discuss these 6 questions of infinite series. So let's start. Question number 3a, test the convergence of the series 1 upon n square plus 1. Now, first of all, we will discuss to solve this sum which test is useful. Okay. Now, first observe that this series is what? Positive term series, because here all terms are positive. Okay. So this one is positive term series. Also, previously what we have discussed? If in numerator or denominator polynomial is given, then we can apply comparison test. See, yes or no? So here polynomial is given n square plus 1. So that's why to find the convergence of this series, we will use comparison test. Okay. So now let's discuss what is the comparison test and how to apply comparison test step by step to find the solution. P series. The P series 1 upon n raised to p, where p is a real constant. This series is converges if p is greater than 1 and diverges if p is less than or equal to 1. So here what is given? This one is a form of P series. Summation of n is 1 to infinity 1 upon n raised to p. Now what is P? P is a real constant. Now from the knowledge of P, we can conclude the behavior of this series. Means if P is greater than 1, then we can say the given series is convergent series. And if P is less than or equal to 1, we can say the given series is divergent series. Got it? For example, now this one is a P series 1 upon n raised to p form. Now here what is P? P is 3. And what is 3? 3 is greater than 1. Okay. Means P is greater than 1. So from this, if P is greater than 1, what we can say? The given series is convergent series. So this series is what? This series is convergent series. Okay. So from the knowledge of P, we can easily conclude the convergence and divergence of the P series. The next is geometric series. A geometric series is of the form a plus ar square plus ar raised to 3 and so on, where a is the first term and r is the common ratio. If we have a knowledge of r, then from this table we can conclude the behavior of the series. If mod r is less than 1, mod r is less than 1 means mod r means minus 1 less than r less than 1. Okay. If r is lie in this range minus 1 to 1, then the given series is convergent series. If r is greater than or equal to 1, the given geometric series is divergent series. and if R is less than or equal to -1, the given series is oscillatory series. Okay. For example, suppose the series is now here. Now let's check whether this one is in this form or not. Now this one 2 is my first term, so 2 is as it is. Now A into R, so 2 into 2 we can write, plus 2 into 2 square, okay, plus 2 into 3 square, okay, and so on. Now compare this with the given form. This is my A into R, A into R square, A into R raised to 3, and so on. Okay. So here what is A? For my given series, A is what? A is equal to 2. And what is R? R is also 2. R is a common ratio. Okay. And ratio remain constant. R is 2. Now from this table, R is what? Greater than 1. Okay. If R is greater than 1, then what we conclude? The given series is divergent series. That's why this geometric series is what? Divergent series. Okay. Limit comparison test. Let series AN and series BN be two series with positive terms. That is AN greater than 0 and BN greater than 0 for all n. Suppose that limit n tends to infinity, AN upon BN is equal to L. Now what is the value of L? L lies in a range 0 to infinity. Then either both series AN and series BN converge or both diverge. So what does it mean? If AN and BN be two positive series and this condition is satisfied, limit n tends to infinity, AN upon BN is equal to L, where L lies in a range 0 to infinity. If this condition is satisfied, then what we can conclude? Both the series AN and BN converge or both diverge. Means if series AN is convergent series, then BN is also convergent series. If AN is divergent series, then BN is also divergent series. Okay, and vice versa. If BN is convergent, then AN is also convergent. If BN is divergent, then AN is also divergent. Okay. So, how to apply this test? For this, step 1, first of all, series AN, this one is my given series. Okay. Now, for this given series or for this given series, find other series BN. Okay. Now, what type of series BN is? So, BN is a series whose convergent or divergent we already know. Already know means BN series का form क्या होना चाहिए? BN series is either P series और geometric series. क्योंकि P series और geometric series का convergent और divergent हम easily find कर सकते हैं. Okay, from the knowledge of P and from the knowledge of R. Okay, तो हमें क्या करना है? For the given series AN, find other series BN. और ये BN series क्या होनी चाहिए? जिसका convergent हमें पता हो. मतलब कि BN series हमारी either P series होनी चाहिए या फिर geometric series. Third step हमें क्या करना है? Find this limit. If L lie in this range, then what we can say? If series BN is convergent, then AN series is also convergent. If BN is divergent, then AN is also divergent. Okay? ये टेस्ट में ऐसा नहीं होगा कि अगर AN कन्वर्जेंट है तो BN डाइवर्जेंट होगी या फिर BN कन्वर्जेंट है तो AN डाइवर्जेंट होगा. ओके, अगर ये कंडीशन सेटिस्फाई हो रही है, देन बोथ द सीरीज AN and BN converge or both diverge. Okay, these two series have the same behavior. So this is the comparison test. Here what we are doing, we are comparing the behavior of one series with the other series, and on that base we give the conclusion. Okay, so that's why this is known as the comparison test. Now let's find the solution. Question number 3a. Now find the convergence of this series 1 upon n square plus 1. So as we discussed earlier, this one is a polynomial, so that's why to find the convergence of this series, here we are using comparison test. So as we have discussed earlier, to find the convergence of this series, step 1, this one is a given series an. Okay, the given series is written as series an. For this given series, first of all, we have to find series bn. So my bn series is what? Series 1 upon n square. So now let's discuss how to find this series bn. As we know that for very large n, one upon n square plus 1 is approximate same as 1 upon n square. Can we see or not? For very large n, 1 upon n square plus 1 is approximate as 1 upon n square. For example, suppose I have 1 upon 100 square. My n is 100. So 1 upon 100 square plus 1 is approximate to 1 upon 100 square. Say yes or no? 1 upon what we get? So this number is approximately same or not? For very large n. Okay. So 1 upon 10,001 is same as 1 upon 10,000. Say yes or no? So here for very large n, can we write 1 upon n square plus 1 is approximate as 1 upon n square? Okay, so that's why this one is my bn series. So what we assume? Bn series is what? 1 upon n square. And as we discussed earlier, this one is what? P series. सही है? तो bn सीरीज हमने एक ऐसी सीरीज फाइंड की है जिसका कन्वर्जेंट हम इजीली फाइंड कर सकते हैं. bn सीरीज क्या होनी चाहिए? आइदर p सीरीज और ज्योमेट्रिक सीरीज, दैट वी ऑलरेडी डिस्कस्ड अर्लियर. ओके, तो bn सीरीज क्या है? 1 अपॉन n स्क्वायर. नाउ अप्लाई लिमिट कंपैरिजन टेस्ट. फाइंड limit n tends to infinity an upon bn. So this is same as limit n tends to infinity. What is an? An is the given series 1 upon n square plus 1. And what is the bn? Bn is the new series, okay, 1 upon n square. Now evaluate this limit. So now simplify this. So we get n square upon n square plus 1. न्यूमरेटर और डिनोमिनेटर एक्सचेंज हो जाएगा क्योंकि डिनोमिनेटर अपॉन डिनोमिनेटर है. So n square upon n square plus 1. Now here put n square as it is. In denominator take n square common. So we get 1 plus 1 upon n square. So these n square is cancel out. We have 1 upon 1 plus 1 upon n square. Now apply limit n tends to infinity. So here 1 upon infinity is what? This value is become 0. So what we get? Answer is 1. So as per the limit comparison test, what is the condition of L? This one is nothing but my capital L, okay? So what is the capital L? Is lie in a range 0 to L less than infinity. If L is lie in a range 0 to infinity, then what we conclude? Series AN and series BN either converge or diverge together, okay? Here L is 1 and L lie in a range of 0 to infinity. So that's why what we conclude? Both the series AN and BN either converge or diverge together. मतलब कि अगर BN सीरीज कन्वर्जेंट है तो AN भी कन्वर्जेंट है, BN डाइवर्जेंट है तो AN भी डाइवर्जेंट है. बराबर है? अब नेक्स्ट स्टेप क्या होगा? नेक्स्ट स्टेप हमें क्या करना है? BN का कन्वर्जेंस चेक करना है और BN के कन्वर्जन के बेस पे हम AN का कन्वर्जेंट फाइंड कर सकते हैं. ओके, सो नाउ लेट्स फाइंड convergence of series Bn. So let series Bn is equal to summation of n is 1 to infinity 1 upon n square. Now what type of series is this? Okay, so this is a P series. with p equal to 2. And as we discussed earlier, p greater than 1, the series is convergent. So that's why the given series Bn is convergent series. Okay. Now Bn is convergent, and also from this what we can say, series An and series Bn either converge or diverge together. Okay, so that's why Bn convergent है तो An भी क्या होगा, An is also convergent series. So to find the solution of this, what we did, first for the given series An, find series Bn. Now how to find Bn? This one is the real method. Okay, if you find to Bn using some trick, then what to do? Here from numerator, find the next maximum power of n. So in numerator, what is the maximum power of n? Here 1. 1 means n raised to 0. And in denominator, what is the maximum power of n? N square. Okay. So what is the value? N raised to 0 is 1. 1 upon n square. Okay. So what is my Bn? Bn is 1 upon n square. Okay. After finding Bn, find the limit. If L is lie in a range 0 to infinity, what we can say, series An and Bn converge or diverge together. Then find convergence of the series Bn. Here series Bn is convergent. That's why from this what we can say, An is also convergent. Okay. Question number 3b. Test the convergence of the series minus 1 raised to n plus 1 upon n. Now see here, this series is alternating series because here minus 1 raised to n is given. Okay. So here when you put n 1 by 1, first put n equal to 1. So 1 plus 1 2, we get positive 1, 1 upon 1. Now put n equal to 2. So 2 plus 1 3, negative. So we get 1 upon 2. Now put n equal to 3. So 3 plus 1 4, positive. So we get 1 upon 3 and so on. Okay. So this series is what? Alternating series. Here alter the sign, plus minus and so on. Okay. So this is the alternating series. So for this, first of all we will discuss the Leibniz test, and also for alternating series, what is the absolute convergence and what is the conditional convergence. Okay. Alternating series. A series is of the form minus 1 raised to n minus 1 an or minus 1 raised to n an. Then this series is known as alternating series. Okay. So now to check the convergence of alternating series, we use Leibniz test. So what is the Leibniz test? The alternating series converges if the following conditions are satisfied. First condition is mod an plus 1 is less than or equal to an for sufficiently large n, and limit n tends to infinity mod an equal to 0. Okay, if these two conditions are satisfied, then we conclude the given series is convergent series. If any one condition or both the conditions are not satisfied, then this series is divergent series. Okay. Next is, if alternating series is given, so in this case we need to check whether the given series is absolute convergence or conditional convergence. So how to check? A series An is said to be absolutely convergent if series mod An is convergent. Okay, means series An is what type of series? Series An is alternating series. For this alternating series, take absolute value. So after taking absolute value, this become positive term series. Okay, then check the convergence of this positive term series. If this positive term series is convergent, then it is absolutely convergent. Okay. Next is conditional convergence of a series. a series AN is said to be conditionally convergent if series AN is convergent but series of absolute value of AN is divergent. Okay, after taking absolute value means this series is alternating series, convert it into positive term series. Okay, so after converting it into positive term series, if it is divergent, then what we conclude, this is conditionally convergent. मतलब कि अगर उसकी एब्सोल्यूट सीरीज क्या है, कन्वर्जेंट है, तो वो एब्सोल्यूट कन्वर्जेंट है, और अगर उसकी एब्सोल्यूट वैल्यू कन्वर्जेंट नहीं है तो वो क्या है, कंडीशनली कन्वर्जेंट है. ओके, now here this is the alternating series, so that's why apply Leibniz test. First of all, find AN. So what is AN? This series is of the form minus 1 raised to n plus 1 upon AN. So my AN is what? 1 upon n. Okay, so AN is 1 upon n. What is AN plus 1? So this is the nth number of term. In nth number of term, n is replaced by n plus 1. So we get an plus 1 is 1 upon n plus 1. Now compare here. So mod 1 upon n plus 1 is obviously less than 1 upon n for all n. Say yes or no. यहाँ पे क्या है, डिनोमिनेटर क्या है, ज्यादा है विथ कंपेयर टू दिस, तो एंटायर नंबर क्या होगा, ये नंबर इससे लेस ही होगा फॉर ऑल वैल्यू ऑफ एन. से यस और नो. जैसे यहाँ पे n इक्वल टू 1 पुट करो तो 1 अपॉन 2 इज लेस देन 1, 1 अपॉन 3 इज लेस देन 1 अपॉन 2. पुट n इक्वल टू 4, so 1 upon 5 is less than 1 upon 4. Say yes or no. So for all n, this inequality satisfy. Okay, so we can say mod an plus 1 is less than mod an for all n. So first inequality is satisfied. Second condition, find the limit. Limit n tends to infinity mod an is equal to limit n tends to infinity, an is 1 upon n, so mod an is also 1 upon n. Now put n equal to infinity, so 1 upon infinity is equal to 0. Okay, so hence both conditions of Leibniz test are satisfied. Therefore the given series is convergent series. Okay, now this is the alternating series, so that's why we need to check whether it is absolute convergent or conditionally convergent. Okay, so that's why for this alternating series, take its absolute value. So now series minus 1 raised to n, n plus 1 upon n, take its absolute value. So this negative become positive, so what we get, series 1 upon n. So now after taking absolute value, this alternating series become what, positive term series. Okay, now check the convergence of this positive term series. So what type of series is this? This one is a P series, 1 upon n raised to p form, 1 upon, this one is my P series, and what is the form, 1 upon n raised to p. Okay, with p equal to what, 1. So from the condition, if p is less than or equal to 1, the series is divergent series. Okay, so that's why this absolute series is what, divergent series. So as we discussed earlier, if this absolute series is divergent, means it is conditionally convergent. Okay.